Hello everyone, and welcome back to my channel. Today, we are discussing an amazing greedy algorithm problem that is commonly asked in coding interview and competitive programming, like minimum size of a containing set. Here, we are given interval and we must select the minimum number of integer such that every integer in interval contain at least two integer from our chosen set. This question is all about precision, greedy choice and clean logic. So let's break it down step by step. So we have to just take about the concept. Before we jump into the code, let me explain the core idea in simple word. When you need to cover interval with points and each interval need at least 2 points, the smartest strategy is sort intervals by endpoint. Always try to pick point from the right side. Reuse previously selected number as much as possible. Also, add new number only when necessary. Track only the two largest chosen point P1 and P2. This greedy idea ensures we always choose point in best possible place to help future interval. Now comes to the code. Like we will explain code with full line by line explanation. So in first line, class solution diff intersection size to self comma interval. Okay, here we create our solution class and define the main function. Okay, in line number 3 we sort the interval first by their ending point. If the two are same, choose the one with large start first. This sorting is crucial. It ensures the greedy strategy work and we can reuse pointing effectively. P1 is equal to minus 10 into 18, which is a smaller point, and P2 is equal to minus 10 into 18, which is larger point. These represent the two largest point we have selected so far. We start them at a very small number so that initially no interval contains them. In P1, which is a smaller as we have said previously, and also P2 which is larger, ans is equal to 0. Okay, this variable will count how many number we add to our containing set. Now come to the line number 9. Here we iterate through every interval, that is L means left boundary and R means right boundary. So here we have taken the cases. Like in first case, no selected point is inside the interval if I is greater than P2. Okay, if even our largest point which is P2 is smaller than the interval start, then there are 0 selected point inside the interval. So we must add two new point, that is P1 is equal to R minus 1, P2 is equal to R, and ans plus is equal to 2. We choose point at the rightmost side, that is R minus 1 and R. Rightmost point give a maximum chance to help future interval. Increase number by 2 here in line number 14 which we have described. Now comes to the line case 2. Exactly one point is inside, that is if 1 minus 1 is less than P1. This means P2 is inside but P1 is outside, so we have one valid point and we need one more. If R is equal to P2, P1 is equal to P2 and P2 is equal to R. So if interval in R is not equal to existing point P2, we simply add R as new point. So we have to take a shift, that is old P2 becomes new P1, new point R becomes new P2, else P1 is equal to R minus 1 and P2 is equal to R. Okay, in a special case, if R is double is equal to P2, then the new points cannot be the same as the exacting point. So we add R minus 1. So ans plus is equal to 1. So we add one more point here, that is case number 3 as else already covered. Okay, so both P1 and P2 lie in the interval, so nothing need to be added. So we have taken return else. Finally, return to the total means minimum number of integers needed. So here from this question we have a conclusion point too, that the heart of this problem is understanding that when interval overlap, the choosing number at the rightmost position allow maximum reuse. By sorting the interval and tracking only the two largest points selected so far, we ensure minimum addition, maximum reuse, optimal greedy behavior. This strategy guarantees the smallest possible containing set. So, and that brings us to the end of the today explanation. I hope you found this breakdown helpful and easy to follow. So if you enjoyed the clear step-by-step logic, please make sure to like the video, subscribe and share it with your friends preparing for coding interview. Your helps the channel grow and motivate me to grow more high quality explanation. Thank you so much for watching, and I will see you in the next video with another powerful algorithm. Until then, keep practicing, keep learning and happy coding. Bye bye.